Hi everyone, welcome back. Today on our board we are looking at this expansion and these are nice questions on compound angle formula. Last time we looked at compound angle formula and its derivation and the video is popping up on the screen here. After watching this video you can go ahead and also see in full how the derivation is done, and in today's video we are applying what we learned from that derivation. And all this said, let's go ahead and remember this formula before we start tackling our question. Yeah, so those are the four formulas we derived last time, and today we're going to look at how to apply them, and at the same time we're also going to review some double angle formulae we also look at in previous lessons. So let's take a look at our first question here that says expand the following cos x minus 20. Now when you look at this question, part A is looking exactly like this last one here, because we see between the angles we have subtraction. Now meaning we're going to expand it to look like this. And one thing we have to note with cos expansion here is that we have cos and cos in both of them. And then the difference is whenever we get positive here, and then this must be negative. If this is negative, here would be what? Positive. And that is how this cos compound angle works. So let's go ahead and start getting solution for the first one. So for part A, this says we need to expand cos of angle x minus 20. And here, this is equivalent to what I've just written here. That is going to be cos of A, and our A is here, x. Then we multiply it with cos of B, and our B is 20. And the sign here is addition. Sine of A, our A is x, times sine of B, and our B is 20. So we've already expanded this because there's nothing we can do. We just have to expand. So let's move on to part B of the question that says we're expanding sine of x plus 20. And this is the same like the first one here. When you look at the first one is a plus b, and here we're adding these two angles together. Therefore, we'll have the sine of our a, and our a is x. Then times cos of b, and our b here is 20. And we'll add it together because here is addition. And have cos of a, and our a is x. Times sine of b, and b here is 20. So we've also expanded it successfully. Here, let's move on to the next one, and that is part C. So for part C, we have two options of working out this. The first one, I need to walk us through looking at expansion using compound angle. Then the second one, we'll use also double angle. Compound angle, we can split this angle into two, just that we have sine of 2x plus 2x to represent A and B. So when you sum them together, you get back 4x. So we have not make any change. Now let's move on and get this to the second part here, and we continue with our expansion. Therefore, sine of 2x plus 2x is the same as the first one. So we're starting with sine of 2x and cos of 2x. So the sign in the middle is plus, and we have cos of 2x, and multiply this by sine of also 2x. And this is the same as algebraic expressions that can be simplified, but the difference only here is the arrangement. So when you have like 2 times 3, you get 6, or 3 times 2, you get also 6. So for that case, we can make them look the same, like starting with sine instead of cos here. So let me rearrange for us to be able to figure it out clearly. Now the first term here remains the same, that is sine 2x times cos of 2x, and then plus this time I'm starting with this, and we have sine of 2x times cos of 2x. Clearly you can see they are really looking the same. Then from algebra, you just add the two together. Just simply like saying 2a plus 2a, we get 4a. The same thing here. So 1 of this term plus 1 of the other term here, we get 2 of the same term, sine of 2x cos of also 2x. And that becomes the solution for our sine for x. Now again, I told you already that I'm going to work this one here in a different way and using double angle formula. So how is double angle formula work? Another solution for this one is when you have sine of 4a, you first need to remember our double angle formula for sine. So sine of any angle, or let me say 2 alpha, is given by twice sine of alpha cos of alpha. So that is the formula for sine double angle. For cos, we have 3 of them. We'll see it in a minute. Now, when we take a look at what we have here and we place it underneath, we have sine of 4x. Now, let's take a study. We have 2 alpha here and here we have only alpha, meaning we get half. Sorry, I think this is alpha. It's not x but alpha. So we take half of this angle here to appear in our splitted sine and cosine. So the same thing, the 2 is from the formula, will remain here, and we have sine of, instead of alpha, now this 4x will be divided by 2 to get 2x. So we have here 2x times cos of also 2x. So when we take a look at our answer, we're going to use another method. It's exactly the same. So you can use any of the two approaches, either double angle or compound angles, to get this expansion. So from part D of the question, it says get an expansion of 4 cos 10x. So let's move on and also do the same thing. So lastly, part D of question number 1 is saying cos of 10x. Let us go ahead and work it using the 2 ways. So firstly, I'll forget about our 4 and let's put our 4 somewhere here. So let me write this in terms of the sum of the angles. So we have cos into bracket 10x and be split it into 5x plus 5x. And here we can move on and work on this expansion before multiplying with what we have here. Therefore, if we keep on maintaining our 4 outside here and we make expansion of what is inside here, remember when we are adding, then somewhere we'll have subtraction from our formula. We look at up there. Therefore, we would have here cos of 5x and also cos of 5x, and we subtract away sine of 5x, sine of also 5x, because the angles are the same. So we can close this bracket up and we'll take a look on how we can simplify this. So when we look at the first one here, we have cos square 5x minus, when we multiply this, sorry, there was x missing here, we have also sine square 5x, and that is the bracket. Now we can open up this bracket to expand it fully, and we have something like 4 cos square x minus again 4 sine square 5x. But remember, this is not the only solution when it comes to cos. What is the other solution that we might have when it is also using the same expansion using double angle formula? Now from here you can see that for double angle formula there are 3 of the formulas. Maybe let's go ahead and first remember them. When we have cos of, maybe say 2a, this is given by 3 expressions. So the first expression here is similar to what we had here. That is equivalent to cos square a and we subtract away sine square A. And when you look at this exactly, we started with cos, then subtraction and sine. So another method would be different, and the second one here would be 1 minus twice sine square A. Take note that we have 2A here, and then we also have half of this angle A. Then the third approach will be to cos square A minus 1. So apart from this answer, which is correct, somebody might have taken this and find different answer, but meaning the same thing. Therefore, let's work this also using the same thing here, and that is 4 cos 10x. So if you have taken this one here, this is the same as 1 minus twice sine square, and half of 10 is 5, so 5x. That solution is similar to this solution we have just marked here. Let's move on also, and we get the last solution for the same thing using a different approach. That is the last formula. So we have cos of 10x and also be given the same as, starting with twice sine square, and half of 10 is 5. So we have 5x minus 1. And this is giving us the same expression. By the way, you can go ahead and use the first answer we've gotten and change one of the triggers, so either sine or cosine, and replace to one of these answers here. So from here, question 1 is done. Let us move on to question number 2. Now in our question number 2, we have to simplify the following. Remember question 1, we were expanding. We have been given expanded form and are required to simplify it down. How do you approach this? It's the same way. And let's move on and take part A of the question and we start simplifying. This says you need to simplify twice sine of the given angle is 3x times cos of 3x. So using the approach of double angle, we already know that for a double angle, when you're given sine of any angle, and let's make here twice A, this is the same as twice sine of a single angle here, that is A, times cos of the same angle A. Now since we're given this, we need to write it in this form. So let's bring in our given expression here and write it beneath our formula, and twice sine of 3x cos of 3x. And here we need to get exactly what is on this side. So the two remain the same from the formula, and we can move on to this side here. So our A is 3x. Now since we have 2 here and multiply by this 3x, it means we double it to 6x. Therefore, our solution is sine of 6x. And that is the answer for part A of the question. Part B is from cos expansion, where we have 2 cos, the meaning of this is power, so this one is the same as 2 power 2, and the angle is 6x minus 1. So from double angle formula, it says cos of 2a. The last one we saw from question number 1 is twice cos square a minus 1. Now let's take a look at here. That is the same thing. So when we have twice cos square 6x and we subtract away 1, what is the expansion here? So it will be cos of our a here is corresponding to 6x. So here twice a means 2 times 6x, and that is 12. So that becomes our answer. So lastly, let's take a look at number C. And our part C is saying 8 sine of 5x times cos of the same angle 5x. Now one thing you need not to worry about is this 8 here, because somewhere we have this expression with 2, meaning we can make this 8 as a multiple of 4 and 2. So we have here 4 into 2 sine of 5x, and we multiply this by cos of 5x. Of course, when you open it up, it takes us back here, and therefore, the next step is to see that this is sine expansion. Now, when we get our solution here, we'll have our 4 multiplies the answer of saying sine. Also recognize that this is from sine double angle formula. So from here, 5x will be double to 10x. And that becomes the solution for this question here. And these are the 3 parts we have just solved for question number 2. If you have watched up to this time and you have not subscribed to the channel, go ahead and subscribe to the channel so that you can be a member and be able to also get notification for my upcoming video. In our next video, we'll also look at advanced questions that requires the same approach of compound angle formula or even double angle formula to make a revision. So see you in that video. Peace out.